The Starliner has landed safely, but the journey back was anything but smooth. Thruster malfunctions and a navigation glitch created unexpected challenges during its return. So, what exactly went wrong, and how does this affect Starliner's future? Join us as we look into the key moments of the return, the challenges Boeing now faces, and what's next for this ambitious spacecraft. On September 6th, Starliner began its carefully planned journey back to Earth. After months docked at the International Space Station, ISS, the spacecraft successfully undocked at 6:04 p.m. EDT and initiated a series of critical thruster burns to adjust its trajectory for re-entry. But, as it prepared for the descent, a series of unexpected issues emerged. Several thrusters, crucial for controlling the spacecraft's movements, overheated, and one failed to fire completely. How did Starliner manage to land safely with these failures? Backup systems designed for such emergencies took over, ensuring the spacecraft could continue its descent through Earth's atmosphere. During the re-entry, Starliner launched its service module, allowing it to burn up as planned. The thruster malfunctions, though concerning, were overcome by Starliner's engineering, demonstrating the spacecraft's resilience. Despite these technical hurdles, when the Starliner reached White Sands, New Mexico, it safely released its parachute and made a controlled landing. This successful landing highlighted Boeing's ability to handle mid-flight anomalies, but it also raised questions about the spacecraft's readiness for future crewed missions. One of the most significant challenges during Starliner's return was the malfunction of its thrusters. As the spacecraft began its critical descent phase, NASA engineers noted that the service module thrusters were experiencing higher than expected temperatures. These thrusters are crucial because they control the spacecraft's orientation and trajectory during return, where heat and pressure build up rapidly. As temperatures continued to rise, one of the thrusters completely failed to activate, triggering alarms in mission control. This malfunction occurred at a vital point in the mission, just before the spacecraft was set to discard its service module and prepare for its descent into the atmosphere. Thruster failures are particularly concerning in such situations because precise control is required to avoid the spacecraft tumbling or deviating from its intended path. A deviation during landing could lead to catastrophic consequences, such as uncontrolled landing or damage to the spacecraft. However, Starliner was prepared for this scenario. Boeing engineers had built the spacecraft with multiple layers of redundancy. When the main thruster failed to respond, a secondary thruster automatically took over. This backup system was critical in ensuring that Starliner maintained its orientation and continued its descent without any major disruptions. The primary thruster issue posed a risk, but the backup systems activated, ensuring a smooth landing. Although the backup thrusters prevented disaster, the overheating and failure of the primary systems remain a significant concern. NASA and Boeing now face the challenge of understanding what went wrong. During post-landing assessments, engineers will need to thoroughly analyze the performance of these thrusters, particularly the overheating issues, to ensure that future crewed missions are safe. With humans on board, any failure of critical systems could pose a serious risk. Beyond the immediate technical assessments, this incident raises larger questions about Starliner's reliability as a vehicle designed for human spaceflight. Thruster malfunctions in uncrewed flights provide critical lessons, but they also put pressure on Boeing to demonstrate that these problems can be resolved quickly and effectively before astronauts board. With plans for Starliner to serve as a reliable transport to the International Space Station, NASA and Boeing need to ensure that the spacecraft's systems can handle the stresses of space travel and re-entry without compromising crew safety. Unexpected events occurred as Starliner returned to Earth's atmosphere. After the thrusters had already caused their own set of challenges, another critical system, the navigation system, experienced a brief malfunction. The capsule's primary navigation system, crucial for guiding the spacecraft to its intended landing zone, failed momentarily, leaving mission control concerned about its ability to stay on course. This failure occurred just as the spacecraft emerged from the plasma blackout phase, a period during landing when communication with Earth is temporarily lost due to the extreme heat and ionized gases surrounding the capsule. Once communications were restored, NASA's engineers noticed the navigation system glitch, which could have led to a serious deviation from the planned landing location. However, similar to the thruster problems, Starliner's backup systems stepped in to prevent any major issues. The backup navigation unit was able to take over and safely lead Starliner through the remaining portion of its descent when the spacecraft's redundant systems soon activated. Despite this anomaly, the landing procedure proceeded as planned. The mission successfully concluded with this, much to the satisfaction of NASA and Boeing engineers who had been constantly monitoring the situation. While the mission ended safely, the navigation glitch adds another layer of complexity to the issues Boeing will need to address before future crewed flights. The anomaly, though brief, underscores the importance of refining Starliner systems to ensure reliable performance when human lives are at stake. Now that Starliner is safely back on Earth, the focus shifts to Boeing's next steps in resolving the technical issues that surfaced during the spacecraft's return. Boeing faces a significant challenge as they must address the thruster malfunctions and navigation anomalies that occurred mid-flight. With Starliner already facing scrutiny due to previous delays and technical problems, NASA and Boeing need to carefully assess whether the spacecraft is ready for a crewed mission. One of the most pressing concerns is the reliability of Starliner's thrusters. The overheating and failure of one of the thrusters during the descent raised serious questions about the spacecraft's capacity to handle the demands of a human-rated mission. Similarly, the brief failure of the navigation system during re-entry has sparked further investigations. These issues are especially critical as the next mission will involve a crew, meaning that any technical malfunction could endanger human lives. Currently, Starliner is undergoing extensive inspections at Boeing's facilities in Florida. Engineers are carefully analyzing the spacecraft to determine the root causes of the thruster and navigation problems. The service module, which hosted most of the malfunctioning thrusters, is being closely examined to identify if design modifications are necessary to prevent future overheating. Boeing is also focusing on the navigation system, exploring potential software upgrades or hardware adjustments to ensure smoother performance in future missions. In addition to repairs, Boeing is planning a full upgrade of Starliner, ensuring the spacecraft is in top condition before its next flight. This maintenance process includes replacing key components and upgrading systems based on data collected from the recent mission. With the next crewed flight scheduled for 2025, Boeing must ensure that all technical issues are thoroughly resolved to meet NASA's stringent safety requirements. While the recent issues during Starliner's return have raised concerns, both NASA and Boeing are determined to press forward. The goal remains to have Starliner certified for crewed missions, and Boeing is working hard to address the technical problems encountered during this mission. Despite the setbacks, Boeing and NASA are still aiming for a crewed flight in the near future. The focus now is on conducting thorough inspections and resolving the issues with the thrusters and navigation systems. These fixes are critical, as the spacecraft will eventually be carrying astronauts, meaning safety and reliability are essential. NASA officials have expressed confidence in Boeing's ability to overcome these obstacles, but they are also aware that ensuring everything is in top shape will take time. The initial plan was to have Starliner's first crewed mission in early 2025. However, given the recent challenges, this timeline could be pushed back as Boeing works to fix the identified issues. Each test flight, like this one, provides valuable data that helps engineers refine the spacecraft, but it also adds to the growing list of delays. With the next mission scheduled for August 2025, Boeing faces the difficult task of proving that Starliner is safe and reliable for human spaceflight. The pressure is on, as the company has already faced criticism for previous delays and technical setbacks. However, with significant resources dedicated to solving these issues, Boeing remains optimistic about the future of the program. The implications of further delays go beyond Boeing. NASA is depending on Starliner as a part of its commercial crew program, which aims to increase the number of spacecraft available for missions to the International Space Station. The sooner Boeing can get Starliner back on track, the sooner astronauts can safely fly aboard it.